Good day, everyone. This time we're going to start discussing another lesson in assessment of students' learning. To start with, let us proceed to the next slide. Now we have here a table showing the ranking of scores. Now the question is, how can we rank scores or grades? Now I have here the first column showing the different scores. Let us say these are the scores of um, 11 students. Let us say that the test is 1 to 20. So you have here the results. Now the question is, how are we going to rank these scores at the first column? So the first step is to write an array. An array is the arrangement of scores from highest to lowest or vice versa. So let us say that the arrangement is from highest to lowest. So the highest score at the first column is 19. So you're going to put that there at the top. The next score is 16. So that will be the second, followed by 15, then down to 4. You will notice we have 3 12s. You are also going to write the 3 12s there and 2 8s. Be sure that the arrangement is from highest to lowest. Then we have the next column, which is all about the number. You're just going to write the numbers from 1 down to 11. So if you have, let us say, 15 scores, the number there will be 1 to 15. If you have 20 scores, the number will be 1 to 20. And then after that, the last column is all about the rank. As you can see, 19 is the highest, so that will be first in rank. So rank number 1. And then 16 is the next number, so that will be rank number 2. 15 is the third number, so that will be rank number 3. And then 15 is followed by 3 12s. So what will be the rank of 3 12s? Now look at the number part. The 3 12s occupy these slots for number 4, 5, and 6. So to get the rank of these three numbers, 3 12s, you just get the middle number, 4, 5, 6. So the middle is 5. So that the rank will be 5 or fifth. And then the next number is 9, or the next score is 9, which is opposite the number 7. Therefore, the rank will be 7 also. So it is 7 because the three numbers there, 5, 5, and 5, occupied 4, 5, 6. So that will be followed by 7. Now, 9 is followed by 2 8s. Now, these 2 8s occupied the numbers 8 and 9. So the middle of 8 and 9 is 8.5. That's why the rank of 2 8s will be 8.5 and 8.5. The same. Now the next lowest number next to the lowest is 6. And the number opposite it is 10. Therefore, the rank is also 10. Then we have the lowest number, which is 4. The number opposite is 11. Therefore, the rank is 11. Alright, so that is how you're going to rank the numbers. As you can see, we have here the different numbers, and opposite them are their ranks. It is not yet finished because we will proceed to the next table. Here, in our next table, you will notice at the first column that the scores are the original placement of the scores. The first column here is the same as the first column at the previous table. So, the ranking depends on the result of the ranking at the first table. So, say for example, we have here the 19. So, the rank of 19 is 1 or first because it is the highest. Followed by 16, so that is the second. Followed by 15, that is the third, and so on and so forth. So, you're just going to write the correct ranking of the scores here. So opposite the score 19 is its rank 1, and so on and so forth. Okay, so let's proceed. Please remember this because this is very important, and you are going to use this in the Spearman rank correlation coefficient. If you do not know how to rank, then you will not be able to solve the Spearman rho or the R sub S. Now in the next table, you will see this is the computation or how you're going to compute the R sub S or the Spearman rho, which is also known as the Spearman rank correlation coefficient. Now, supposing we have 10 students here, so n is equal to 10. You want to find out if the test given to them is reliable or not. So, in order to test the reliability or to find the reliability of a test, the first method that we have learned from our previous discussion is the test-retest method. And in the test-retest method, the most appropriate measurement or statistical measure to be applied is the Spearman rank correlation coefficient. So let us say that you give the first test. The results are here at the column of X. So under the column X are the results of the first test. And then after some time, you gave the same test to the same set of students. And you have the second result. So the second result is under column Y, meaning to say column X the first result and column Y is the second result. Then R sub X here stands for the ranking of the X scores. So the scores of X starting from 36 down to 45 will be ranked, and that will be put here under the column of R sub X. So these are the ranking of the X scores. R sub Y stands for the ranking of the Y scores. So the highest in Y is 43. That's why the answer here is 1. Second to 43 is 40. But we have 2. That's why it occupied 2 and 3. So the middle of 2 and 3 is 2.5. So we have 2.5 there. And so on and so forth. So in short, you're just going to apply what you have learned in our ranking of scores or grades. Now, the next column is D. D stands for difference. So you're just going to subtract them and you will write the difference here. So you can subtract either from left to right or right to left. What is important is that you will be able to get the difference out of R sub X and R sub Y. So after getting the differences, the last column is D squared. So D squared means to say you're going to square the result under the column. So say for example here 1. 1 is squared, so 1 times 1 is 1. So all of them is 1. Here 0.5 squared or 0.5 times 0.5 is 0.25. So 0 times 0 is 0. And then we have here 3.5 times 3.5 is 12.25. So after completing the D squared column, you are going to add all of them. That's why we have the summation symbol here. So summation symbolizes the sum of all the scores. So if we added all these scores or the column D squared, the result will be 19.5. After getting this, we can now proceed to the computation of the R sub S or Spearman rank correlation coefficient. Now in computing the R sub S from the given table, we are going to follow this formula. The formula is R sub S is equal to 1 minus 6 times summation of D squared all over n cubed minus n. So let us substitute the values so that this will look easier. R sub s is equal to 1. This is the same one here. And then minus the same 6. And then we have already the value of summation of d squared, which is 19.5 at the previous table. And then the value of n is 10. So 10 exponent 3 minus 10. Now let's proceed to the computation. So you will multiply 6 times 19.5, which is 117. And 10 exponent 3 is 1000 minus 10. So 117 minus 990. 990 is the result of subtracting 1000 minus 10. So 117 divided by 1990 is 0.1181818. Repeating decimal, that's why it has a vinculum 18. Then subtract this from 1. The result will be 0.88, sorry. So it denotes high relationship. Now, how did we get this relationship? Or this also means to say that when it is high relationship, the reliability is also high. So it is the same as high reliability. So to find out where did we get this result, we have here the classifications. So an R or a correlation from 0 to plus or minus 0.20 denotes negligible correlation. An R from plus or minus 0.21 to 0.40 denotes low or slight correlation. An R from negative 0 plus or minus 0.41 to plus or minus 0.70 denotes marked or moderate relationship. An R from plus or minus 0.71 to plus or minus 0.90 denotes high relationship. An R from plus or minus 0.91 to plus or minus 0.99 denotes very high relationship. And an R from plus or minus 1, an R plus 1 plus minus 1 denotes perfect correlation. Okay, so our result from the previous table or computation, I think, belongs to 0.71 to 0.90. So that's why it is high, or it has high relationship, or it has high reliability. Therefore, you can say now that the test that you have given is highly reliable. That means to say that is just the right time to say that your test is highly reliable based from the result of your correlation, which is you made use of the Spearman rank correlation coefficient. Okay, so that is how you're going to do it. So that's all. Thank you for listening and good luck in answering the exercises.